Here's another radical equation, and you can see it's complicated because I have a square root with a radical over here, and I have another square root of a radical somewhere else in the equation. So when we think about our first step, remember that's always isolate the radical first. We have this question of which radical do we isolate? Do we isolate the square root of phi, or do we isolate the square root of phi minus 2? The good news is it doesn't actually matter. You can get to the right solution either way. But there is a preference. If you isolate the hard one first, you can make life a little easier for yourself. So let's go ahead and do that. I'm going to just write the equation here. Phi minus 2 equals negative 3 plus square root of phi. Okay, and I'm going to keep this one by itself and then get rid of it by squaring each side. And remember, when you square both sides, you really square the entire side. See how I squared this whole thing in parentheses? So don't forget that. Now, the square roots, part of them anyway, cancels out. That square and the square root cancel out, so we just get phi minus 2. And on this side, you just have to be careful with that, because what this squared term means is you're going to generate some foiling that needs to happen. Okay? So now, let's go through the foiling technique. Remember what foiling means. First, outer, inner, last. Right? So, first one I'm going to do is negative 3 times negative 3. That's positive 9. And then, next one I'm going to do is negative 3 times square root of phi. So that's minus 3 square root of phi. And you see we have another one of those right here. That's negative 3 square root of phi again. And the last term is square root of phi times square root of phi. Square roots cancel out, so you just get phi. So now let's collect all our terms up here. We have phi minus 2 on the left equals 9 minus 6 square root of phi plus phi. So I'm going to subtract phi from each side, and let's see where we get at that point. Negative 2 equals 9 minus 6 phi. Great. Rearrange this a little more. 6 square root of phi equals 11. That's nice. Now, did I add everything right here? Looks okay. All right. 6 radical phi equals 11. So that means square root of phi equals 11 over 6, which means if you square each side, remember how we get rid of square roots? I'm going to square each side here, and that gives me phi equals, multiplication tables, 121 over 36, I think. And now we have to go back and check whether this equation actually works. We have a solution. The question is, does it work? So let's grab our original equation. We're just about done at this stage. There's my equation. I'm going to plug this in here. So I have the square roots of 121 over 36 minus 2. Well, instead of 2, I'm just going to write 72 over 36. If you don't mind, that'll make the fractions easier to deal with. Equals negative 3 plus square root 121 over 36. Now, let's simplify this a little bit. 121 minus 72 is 49 over 36, and that equals negative 3 plus, what's the square root of 121 over 36? Well, that's just the square root of 121 over the square root of 36, right? Okay, think about it that way. And we know these are perfect squares, 121 and 36, so that's going to be equal to 11 over 6. Not too complicated. Remember, that's where it came from. So square root on the left is 7 over 6. So here's my question. Is 7 over 6 equal to negative 3 plus 11 over 6? I still don't know offhand, just looking at it. Keep on working with fractions. This is negative 18 over 6 plus 11 over 6. And that is 7 over 6 equals negative 7 over 6. Oh, look at that. This is no good. This thing is extraneous, and that took us a long time to figure out. This thing's actually a DNE. There is no solution to this equation. It's a big, DNE. Now, don't get upset. Okay, you got the answer to the problem. You're doing everything right. Sometimes, even though you don't make any mistakes, the math just doesn't work out, and that's kind of a life lesson.